Hello students, in our last video we had seen how to solve linear differential equations with constant coefficient if the auxiliary equation have distinct and real roots. Now we shall see how to solve the problems of linear differential equation with constant coefficient if auxiliary equations have repeated root. Suppose an auxiliary equation has a root b n times. B is n times. Then the general solution can be written as y equal to c1 plus c2x plus c3 x square plus so on cn x raised to n minus 1 into e raised to bx. In this way we can write the solution. We can't write c1 e raised to bx plus c2 e raised to bx plus cn e raised to bx. If we write in this way, then this can be again written as c1 plus c2 plus c3 plus cn e raised to bx, and that is nothing but c into e raised to bx, and this will not be general solution because it doesn't contain n arbitrary constants. That's why instead of this we shall write the general solution of this like c1 plus c2x plus c3x square plus cn x raised to n minus 1 e raised to bx if b is repeated roots n times of the auxiliary equation. Now let us solve the problem. Solve the problem or solve the equation d raised to 4 minus 7d cube plus 18d square minus 20d plus 8y equal to 0. First of all, we shall write the auxiliary equation of this. Auxiliary equation is m raised to 4 minus 7m cube plus 18m square minus 20m plus 8 equal to 0. This is auxiliary equation. We have to solve this. For solving this, we shall use triangular method. If sum of all coefficient is 0, then m equal to 1 is root of the equation. 1 minus 7 minus 6 plus 18, that is 12. 12 minus 20 minus 8 plus 8 0. Here sum of all the coefficient is 0, therefore m equal to 1 is the first root of this equation. For finding second root, we shall divide it synthetically by m equal to 1. We shall write all the coefficients 1 minus 7 18 minus 20 8, and we shall carry this 1 as it is. 1 into 1, 1 in minus 7 is minus 6, minus 6 into 1 is minus 6, minus 6 and 18, 12, 12 into 1 is 12, 12 and minus 20 minus 8, minus 8 into 1 is minus 8, 8 and minus 8 is 0. Therefore, the new polynomial will be m cube minus 6m square plus 12m minus 8 equal to 0. Now, here sum of all the coefficient is not 0, therefore m is not equal to 1. Now we shall try by substituting m equal to 2. 2 cube 8 minus 2 square 4 into 6 24 plus 12 into 2 24 minus 8, and 8 minus 24 plus 24 minus 8, this is equal to 0. Therefore m equal to 2 is the second root. Again we shall divide synthetically this polynomial by m equal to 2 or my m minus 2. Therefore 2 is here. We shall write all the coefficients: 1 minus 6 12 minus 8. 1 is as it is. 1 into 2 2, 2 and minus 6 minus 4, minus 4 into 2 minus 8, minus 8 and 12 4, and 4 into 2 8, 8 equal to 0. Therefore new polynomial will be m square minus 4m plus 4 equal to 0. That is nothing but m minus 2 bracket square equal to 0. Therefore m equal to this first one, second root of 10, m equal to 2, and from this m minus 2 bracket square equal to 0 we will get again 2 times 2. 2. Thus the roots of the auxiliary equation are 1 2 2 2. 2 is repeated 3 times. Therefore general solution of the differential equation is y equal to c1 e raised to 1x. Now as 2 is repeated 3 times, we shall take c2 plus c3x plus c4x square into e raised to 2x. This is the general solution of the differential equation. Solve the differential equation: d square minus 6d plus 9y equal to 0. We have to solve the differential equation: d square minus 6d plus 9y equal to 0. We shall write first auxiliary equation. Auxiliary equation is m square minus 6m plus 9 equal to 0, and this is nothing but perfect square of m minus 3, and hence m equal to 3 and 3. The root 3 is repeated 2 times. Therefore general solution is c1 e raised to 3x. General solution is y equal to c1 plus c2x e raised to 3x. d square plus 4d plus 4y. Our problem is solve the equation d square plus 4d plus 4y equal to 0. We shall write auxiliary equation. Auxiliary equation is m square plus 4m plus 4 equal to 0, which is nothing but m plus 2 bracket square equal to 0. Therefore m equal to minus 2 and minus 2. Minus 2 is repeated 2 times, and therefore general solution is y equal to c1 plus c2x e raised to minus 2x. Solve the equation 4d cube plus 4d square plus dy equal to 0. We shall write auxiliary equation. Auxiliary equation is 4m square 4m cube plus 4m square plus m equal to 0. We can take m common. 4m square plus 4m plus 1 equal to 0. Therefore, we will get m into 2m plus 1 bracket square equal to 0. Therefore, m equal to 0, minus 1 by 2 and minus 1 by 2. 1 by 2 minus 1 by 2 is repeated 2 times. Therefore, general solution is y equal to c1 e raised to 0x plus c2 plus c3x as 1 by 2 is repeated 2 times, e raised to minus 1 by 2x. But e raised to 0x is 1, therefore y equal to c1 plus c2 plus c3x into e raised to minus 1 by 2x. Solve the equation d cube minus 8d square plus 16d equal to 0. Auxiliary equation is m cube minus 8m square plus 16m equal to 0. We have to put d by dx d equal to m. Then m can be taken common. M square minus 8m plus 16 equal to 0. Now we have to factorize this m square minus 8m plus 16. This is perfect square of m minus 4. See, m minus 4 square equal to m square, 4m into 2 8m, 4 square 16 equal to 0. Therefore, m equal to 0, 4 and 4. 4 is repeated 2 times, and therefore general solution is y equal to c1 e raised to 0x plus c2 plus c3x e raised to 4x. E raised to 0x is 1. Solve the equation d cube minus 3d square plus 4y equal to 0. For solving this equation, we write auxiliary equation. Is m cube minus 3m square plus 4 equal to 0. Here see sum of all the coefficient is 0. Here if you put m equal to minus 1, then minus 1 cube is minus 1, minus 3 into plus 1 plus 4 equal to 0. Therefore m equal to minus 1 is a root. M equal to minus 1 is a root, first root. And then we shall divide synthetically by m equal to minus 1. M cube coefficient is 1, m square coefficient is minus 3, coefficient of m is 0 and constant term is 4. And minus 1. 1 is as it is, 1 into minus 1 minus 1. Minus 3 and minus 1 minus 4, minus 4 into plus 1 is plus 4. 4 into minus 1 is minus 4, 0. Therefore, second equation is m square minus 4m plus 4, which is nothing but m minus 2 square. This is equal to 0. Therefore, we can write this as m cube minus 3m square plus 4 can be written as m plus 1 into m square m minus 2 bracket square equal to 0. Therefore, m equal to minus 1, 2 and 2. Therefore, general solution is y equal to c1 e raised to minus x plus c2 plus c3x e raised to 2x. d raised to 4y by dx raised to 4 plus 2 d cube y by dx cube plus d square y by dx square equal to 0. Here we shall put d by dx equal to capital D. Our problem is solve the equation d raised to 4y by dx raised to 4 plus 2 d cube y by dx cube plus d square by dx square equal to 0. For solving this, we put d by dx equal to capital D. Therefore, this equation becomes d raised to 4 plus 2d cube plus d square y equal to 0. And its auxiliary equation is m raised to 4 plus 2m cube plus m square equal to 0. Taking m square common, we get m square plus 2m plus 1 equal to 0. M square into m plus 1 bracket square equal to 0. Therefore, roots of this equation are 0, 0 as m square equal to 0 and minus 1 as m plus 1 bracket square equal to 0. Therefore, general solution is y equal to c1 plus c2x into e raised to 0x as 0 is equal to 2 times and c3 plus c4x into e raised to minus x. This is the general solution of the differential equation. Thank you.